Hello everybody, I'm Miss G and I'm going to try to make math a little easier for you today. In this video, we're going to be talking about how to identify three sides on a right triangle, specifically the hypotenuse side, the opposite side, and the adjacent side. Being able to label these three sides is going to be very important because there are four main processes involving right triangles that depend on your ability to name these sides. Specifically, the Pythagorean theorem requires you to use the hypotenuse. Trigonometry, inverse trigonometry, and special triangles all depend on your ability to determine the adjacent and the opposite sides, as well as that hypotenuse. We're going to go through several examples to show how we would identify these sides. The three sides are the hypotenuse, which is across from the right angle, the adjacent, which connects the right angle to an angle that you choose, and the opposite, which connects the right angle to the angle you did not choose. One of the easier ways to do this is by drawing arrows to connect the right angle to these three pieces. For the hypotenuse, I would start at the box and I would go from the corner across the triangle. So here I start at this inner corner of that right angle box and I draw a diagonal arrow across the triangle. That's going to identify the hypotenuse side for me. And you can find that side, the hypotenuse, without any information other than the right angle. The adjacent side, however, requires a second angle to be chosen. In this case, I would choose the 34 degrees, but it is a choice. If I wanted to, I could say, nope, I don't want the 34. I want this unknown angle to be my choice. I can do that. However, when I'm solving a math problem, I want to make a choice that's going to be easier to solve rather than more difficult. And if I choose an angle I don't know anything about, I've now added something else I have to figure out to an already complicated math problem, which is why for me, I would choose the angle I already know, the angle I don't have to find. So in this case, I would start at the box, go from the side of the box to the angle with the number in it. And that's where I'm going to draw this arrow. Now the adjacent side is not the 34. The adjacent side is the outside along that arrow's edge. It is next to the 34, which is what the adjacent means. It's next to. But it's not actually 34. The 34 degrees is the angle measure. It has nothing to do with the side's length. As for our final side, to find that, I would start at the box, just the same, and I would go to the angle that I did not choose. Specifically in this case, the angle that does not have a number in it. Because I chose the 34 and I didn't choose this blank angle, the opposite side is going to be along the edge, going from the right angle to the angle I did not choose. So in this case, the opposite length is 5. The hypotenuse length is an unknown, but specifically it is an unknown that I want, which makes it important. Just like the 5 is important because it's a number, so my opposite matters. But my adjacent is an unknown because it's blank that I don't have, and I also don't have a question for, so I don't want it. Which means in this case, the adjacent would be something that I ignore. When solving this problem, I would use the angle of 34 degrees, the opposite side of 5, and the hypotenuse with the question mark, meaning it's the thing I'm trying to find. Let's move on to another example. This example is slightly different because here we have two side lengths, but on the inside we have a question mark, an unknown. Now that's not going to change my process at all. All it means is that when I choose my angle, I'm going to choose the angle I'm trying to solve for, because why would I waste my time figuring something out when it's not the thing I want? But just like before, I'll start with my hypotenuse, which has nothing to do with that angle at all. It depends only on the right angle. So I'm going to start at the inner corner of my right angles box, draw an arrow across the shape, and I'm going to label that side my hypotenuse. Then I'm going to choose my angle. In this case, I'm going to choose the question mark because it's the thing the problem is asking for, which makes it important. And I'm going to choose the angle that's either information I have or something that's important that I want to find. So from the side of my box, I'm going to draw an arrow to that angle, and along that edge, I'm going to label it as my adjacent. For my opposite side, I'll go from the box to my remaining angle. So from this side to this empty angle that I didn't choose, I'm going to call that side my opposite. So here I have an opposite of 2.8, an adjacent of 2.5, and a hypotenuse that I don't know and also don't want. So this is going to be completely unimportant when I'm solving this problem. I only have the adjacent and the opposite while I want an angle. For this next example, we have the same situation, but it's presented slightly differently. Here we have our triangle, but you'll notice that none of the angles except the right angle are marked. That means one of two things. Either I'm going to make a choice that's completely my decision and has nothing to do with the problem itself, or I'm going to look at the prompt of the problem and it's going to tell me what to do. In this case, the problem tells me that I want to determine the measure of angle L, which means this is the value that I'm looking for. It is my question. So when I get to finding my adjacent, that's going to be important. But to start, it's all about the hypotenuse, and that doesn't require an angle. So for the hypotenuse, I go to the corner of my right angle, I draw an arrow across the shape, and that's going to be my hypotenuse side. And in this case, my hypotenuse is 5.7, which means that's something I can use. Next, we're going to find adjacent. And again, the adjacent side depends on the angle you choose. And because the problem told me to find L, I'm choosing this angle, which makes this outside piece my adjacent. Now notice there's nothing on the outside. There's no number there, and it's not the thing I want. Adjacent is not the question. It's not the thing I'm trying to find. The angle, the inside, is the thing I want. Then finally, for my opposite, I'll go from the other side of the box to the angle I did not choose, the angle I don't want, and that's going to help me identify my opposite, which in this case is 4.4. So when I solve this problem, I'm going to use the opposite value of 4.4 and the hypotenuse value of 5.7 to find the angle value for L. I will not use the adjacent because I know nothing about it, and it's not the thing that I want. For this next example, you'll notice that these two triangles are the same. The only thing that's changed is the question. The first time I wanted L. This time, though, I want N. And the reason that matters is because it is going to affect my adjacent and opposite sides. It will not affect my hypotenuse. For the hypotenuse, I still start at the inner corner, I go across my shape, and that's going to identify the hypotenuse side, which is 5.7. That has not changed. It's exactly the same because the location of the right angle and the side across from it are constant. They don't change. It's adjacent and opposite that depend on an angle. So in this case, the angle I've been asked to choose is N. So that's the angle that I'm going to head toward. And that means that that is going to be my adjacent side. So the adjacent and the hypotenuse both have numbers, and I'll use those when I solve this problem. For the remaining side, I'll go from the outside edge of my right angle to the blank or unwanted angle, which will then give me my opposite. Now in this case, the opposite is not helpful to me. Just like last time, the adjacent was not helpful to me because there's nothing on those sides and they do not have a question mark or a suggestion that that's what I'm trying to find. So for the first example, I would use opposite and hypotenuse. For the second example, it's adjacent and hypotenuse. And those things are different not because the triangles are different, but because the angles I'm using are different. If I change from angle L to angle N, then my opposite and my adjacent switch places. So whenever you switch between those two angles, you switch which side is the opposite and which side is the adjacent, which will affect how you solve your trigonometry, your inverse trigonometry, and your special triangles. For this last example set, you'll notice that both triangles are the same, and they both have two angles with numbers in them. But at no point does the problem tell me which angle I have to use. It doesn't give me any information at all, which means it is entirely my choice which angle I want to use when I do adjacent and opposite. And I won't be wrong no matter which choice I make. I will be able to do whatever process I'm trying to do using the choice I make. So for the first one, I'm going to choose the 27 degrees. For the second one, I'm going to choose 63. Neither is a wrong choice. Each will just be me setting up a problem from a perspective that I have chosen. Now for the 27, the hypotenuse will start at the corner, go across the shape, and be on this bottom segment. That's also true when I choose 63. The hypotenuse is the bottom. Adjacent, however, is going to be different for the 27-degree choice versus the 63-degree choice. Because for adjacent, I'm going to the 27 if that's what I've chosen, making this top left side my adjacent. If, however, I chose the 63, that would make the top right side my adjacent. As for opposite, if I chose the 27, then I didn't choose the 63, so going to that angle would create my opposite. If, however, I chose the 63 and I didn't choose the 27, going to that angle would be the opposite, because opposite and adjacent are about your choice. Adjacent goes to your choice, and opposite goes to the angle that was not your choice. And so, for these two triangles that are the same, the choice that I make changes which side is opposite and which side is adjacent, but it doesn't affect which side is the hypotenuse. The hypotenuse is across from the right angle no matter what, while the adjacent depends on the angle I choose, because by its definition, it is next to the angle I choose, while the opposite is across from and not next to the angle I choose. I hope I was able to be a little bit of help to you, and if you want to help me out by hitting those like and subscribe buttons, I would greatly appreciate it. But if not, I still love you. I hope you're having a fantastic day. Bye, everybody!